let's see. I'm gonna work on exercise 2. So I want you guys to go over the questions here, and after you are done with that, I want you to tell me, maybe you try to fill in the blanks. The blanks are given here. Try to fill in the blanks, and then try to answer the question: is it a numerical variable versus a categorical variable, right? Okay, so
is it numerical? Because there's no like categories of data. It's just numbers.
Well, it's numbers, but previous example, 21%, those are also numbers, right? 0.21, 0.93, those are numbers too, right?
There's no like yes, no. There's no like categories.
Yeah, no categories, because what we are talking about is how much money being saved, right? This is a televisit. So instead of going to the doctor's office, you can just use the online service to ask questions, maybe doing a Zoom chat with your doctor. Okay. So the data given here represents how much being saved, right? So this is how much money being saved. This is clearly a numerical data. And I agree with Canon, this is a numerical variable. Okay. And so let's see how we can fill in all the blanks here. Okay. So which one is the easiest? Which one of those 5 blanks do you think is the easiest to fill? Population.
Sample size is 20.
Sample size is 20, right, Sarah? Okay, great. Okay, so 20, okay. How about the rest? Do we know population mean? What is a population mean? Population mean represents the average of the population. Do we have population? We don't. This is the sample, right? We don't have population. Typically, I mean, if you were in my, in-person face-to-face section, I would, in day 1, I will definitely draw many circles. Population is a much bigger circle compared to a sample you selected. So this is your sample. You could another student, for example, Amy. So Amy select another 20 students, and say Benjamin select another one, and then this is Jackson, Hannah, and Rachel. Who else in my class? Well, it's a small class. I should be able. Nicholas. Okay, let's see. Okay, great. Right, you guys can all have a different sample. So what I want to say here is sample size is very, very small. Population size capitalized. This represents all the doctor visits. Medical doctor's office visits can be out there. It can be thousands and millions, right? It's going to be a huge one. So that's why the sample is going to be much smaller compared to the population. Okay, so do we know the population mean? We don't know it, right? That's why we want to estimate. That's the key here. We are talking about estimation for the population proportion. That was the previous exercise. Now we are talking about estimating the population mean. We don't know it, right? Okay. And how about the population? Okay, so population standard deviation. Do we know population standard deviation? Was it given to us in the question? No, it wasn't, right? Okay, so this part is also unknown. Okay. And okay, so now we talk about 2 summary statistics from the sample. For the sample mean, do we know that? We don't have right away, but we can calculate it, right? Okay, and how about sample standard deviation? So you can use either a calculator or you can use Excel to do it. Do you guys want me to show you how you can use Excel to do it? I've already talked about this before, but I think I should be able to do a quick screen sharing with you in case you don't know how to do that. I know you guys probably have a different kinds of expert, your level, your Excel level can be drastically different. Okay, great. So I'm sharing this Excel with you so you can see how I do it. Okay, so I'm going to delete those information. Okay, so first thing is you have to enter the data into Excel, and typically if you're working on a sinkage problem, so you can just click on it and it should load Excel. Okay, so this is the data I have. For average, I'm just going to write down here sample mean. Okay, what you want to do is you want to type in equal. Okay, and that's you're going to use average, open bracket, and then you're going to highlight all the cells that you need. Okay, you're going to stop here. Okay, close the bracket. press enter. Right, so X bar is 71. Okay, so a lot of you probably know this part. And sample standard deviation. Okay, again, you're gonna press equal. This part is very important. STDEV. As you can probably see here, there are different other options. Okay, so STDEV is gonna be the one that we use. Proportion is the one divided by sample size. Standard EV divides by sample size minus 1. If you remember the formula I gave in week 1 is divided by sample size minus 1. So you're going to use this one, again, open bracket and close bracket. And so you have them right away, right? Okay, so that's, looks neat. Okay, so let's go back to what we had before. Okay, great. Okay, so I'm just going to fill in the numbers we calculated. Okay, so that's 71, and this is 22.35126. I like to write more decimals just to be sure, because this is a very early stage of this calculation. And let's see. Okay, so what we want to do here is we want to develop a 95% confidence interval for the average savings. Okay, so this is a 95% CI for average saving for the entire population. So that's going to be a mu, right? This is a mu. Okay. And what do you need to do for the rest is you would have to use the formula we discussed earlier to solve it. Okay, so let's take a look. So it's a population mean problem. That's what we are doing. But we have two different scenarios, right? When sigma is known versus sigma is unknown. Right, so which one do we use? Because they're using different distribution. The first one is a Z and the second one is a T. So you have to think carefully how you can plug the numbers, right? So I've already written down the formula, and she is gonna do the explanation part on how they work on this problem. Okay. Yes.
Yeah, so the first thing we did was found the degrees of freedom, which is the sample size minus 1, so that's 19 in this case. And then we went to the table and found.
Okay, give me a second. Okay, so so she's gonna explain to us. The first table you guys see is the Z, right? This part is the Z. And so if you go down, it's 2 page, and that's gonna be a T table, which I'm gonna talk more in details later on. So it looks fairly similar. This is called table 2 T distribution. The first thing you noticed is it should be, instead of being left part being shaded, for Z, the left part is being shaded to the left. Over here for T table, it's to the right. This part is very, very important. Yes, you may continue, Sarah.
Yeah, okay, so to find which area it is, you go 100 minus the, or I do like 1 minus 0.95, and then you divide that by 2. And so that number is 0.025. And so you go to 21 or 19 on the degrees of freedom, and then look over to the 0.025 and you get 2.093.
So 2.093. Absolutely right, absolutely. So what is this called? Is this a probability, or is it a score, or is it a multiplier? What is it called?
The T multiplier.
It's called T multiplier, right? Okay, good. And before I like her to go to talk about how she plugged in the numbers, I like to say a little bit more details, if that's okay with Sarah. Okay, so let's see how we find a multiplier. What I like to do is I draw a bell curve. Very, very important. This is a T distribution, right? I'm gonna zoom in a little bit. Okay, and what we are talking about here is 19 degrees of freedom. So right in the center is 0. We want to find a multiplier. A multiplier either is a T or is a Z. It's gonna be a positive one. Okay, so just say we want to find a positive multiplier, and it's gonna be a T multiplier. If we are talking about 95%, that's what the question asked for. 95%, that means I want to find a multiplier. The opposite counterpart to it is going to be negative T. And this multiplier is going to give me the middle area, the area in the middle, to be exactly 95. So I want this part to be 95. Okay, so what kind of a multiplier is going to give you, give me a multiplier, give me an area in the middle is to be 95. So it's going to be 2.093. And Siri has already explained to us how we find that, because if this part is 95%, you should know those two corners. It's going to add up to 5% because the total area add up to be 100%. So each one of them is going to be 0.5% over 2. Over here is also 5% over 2. And that's why it's a 0.025. Okay. And as I said earlier today, T-table gives you the area to the right, right? It gives you the area to the right. So let's take a look. So for this particular one, I'm looking for here, the area to the right is 0.025. And that's why we want to look for 0.025 and 19 degrees of freedom. And they will give us 2.093. Okay, great. And if that part is clear, and Siri is going to help us to fill in the rest of them. Okay, so this is a plus minus 2.093. And how about the rest? How about X bar?
X bar 71.
71, right? And sample size?
N is 20.
N is 20.
And sample standard deviation is 22.2 or 35126.
Right. Okay, so this is how you solve the problem. And again, I like to remind you, the plus minus part, the product of all of them, this entire part is known as a margin of error. This part is going to determine how wide or how narrow your interval is. And how wide or how narrow your interval is going to be dependent on the multiplier, as we were talking about with Canon, right? If your confidence interval is wider, this number is going to be big. For example, right now for 95% is 2.093. You should be able also know that for 90%, this number is going to be smaller than 2.093, right? Okay, you can figure that one out. Okay, so you can plus minus the MOE. And what is the final answer you got, Sarah?
The MOE is 10.46, so the left
lower one.
The lower interval is
yes.
60.54.
Great.
And the upper interval is 81.46.
Great. This is good. This is very, very good. Right? Okay, so you can come in and fill in this one. So make sure you guys carry in the units for it. The units is $sign, so I'm just gonna put this one. So this actually says, on average, about 95% of the intervals is going to contain 95% of the interval. At the 95% confidence level, the average savings for television visit compared to in-person visit is going to be about $90 to $81, right? It wouldn't save like a lot of money, like $100 or $200, but it's going to be on average between 60 to 81.